Hello, everyone. This is Loren Israelsen, founder and president of the United Natural Products Alliance, UNPA. I am here today with Jim Kababik. Jim is the founder and president of Flora Research Labs. Jim is a veteran of the dietary supplement industry, has been for many decades. He's seen it all, pretty much. Jim is a highly respected participant in the analytical community. He is a fellow of AOAC International. He is also interim president of the HPTLC Association of North America. Most of all, he is a friend and a colleague, and the guy I call when I say, Jim, what the hell is going on? So, Jim, it's a pleasure to have you with us today. In particular, as we're approaching the 30th anniversary of DSHEA, we're interested in speaking to people like yourself that bring decades of experience and wisdom, given the many things that you have dealt with, the progress that we have seen in terms of our growth and development as an industry. With that have come growing pains. We've had incidents that we're not proud of. Companies, individuals that have really not understood the spirit of DSHEA, the need to self-regulate, to really do things the right way. And perhaps one of the areas we see this most is in product quality, adulteration, spiking, an area that you're particularly well known for. So Jim, first, welcome, and let's look forward to your insights on how you've seen our industry change and evolve over these decades, and advice. What can we and should we do differently based on what you've seen cross your bench and as you've worked with colleagues around the world for now many decades?
Well, thank you, Lauren. It's great to be here. And as you know, our industry has gone through a tremendous evolutionary change over the last several decades. When I started in the industry, I had blonde hair. And as you can see, I don't anymore. So a lot of work was done, a lot of hard labor by stakeholders, including myself, you, various trade organizations, manufacturers, contract labs, you name it. There were a lot of people to throw in and work hard to raise the bar on the industry. And the first thing I'd like to say is that as an industry, we have a lot to be proud of. We've accomplished a lot in 30 years. We hear about the bad news through major media. We hear about the problems, and there are problems. There are still challenges, but compared to where we were 30 years ago, it's an amazing thing. I mean, I remember seeing C of A's in the 90s for botanicals, and all the C of A said was olive green powder, 40 mesh, 6% ash. Didn't even have an identity on it. In fact, that particular powder was actually a mixture of 3 botanicals, including one that was removed from the market by FDA. So, it's a big difference from where we were. We've established a standard of quality in the industry that's become the norm that wasn't there before. If you look at the amount of testing going on, when I started the lab, I was working the lab nights and weekends, and I had a day job to pay my bills. And everybody said, you're ridiculous starting this lab for an industry that's not going to spend any money testing. You're going to be bankrupt in probably a year if you even make it that far. But I had more belief in our industry. And here we are 30 years later, still not bankrupt, still going strong. And now I have a dozen people working in the lab here, degreed scientists, working on millions of dollars worth of equipment to produce data for companies that care about their product quality. And so, yes, there are challenges, but there's incredible progress. And that's something I'm really glad to see. Some of that through regulatory action, some of that through the norm of what the industry is willing to accept changing. And, that's a big part of it. Education is critical. And we still have companies out there. They reach out to me. I had one reach out just the other day. been in business 35 years, never saw the FDA. They showed up and now they have to do all this stuff that they haven't been doing. And it's not built into their product cost. And it's very challenging. So, it's hard to believe those folks are out there, but they are. And not all of them are flying under the radar for malicious reasons. There's still a lot of just, education to do.
Indeed, Jim. As we've seen, the natural product industry is so vast in terms of individual ingredients and products. It's remarkable. It's hard to think of another industry, consumer industry, that has this kind of variety to deal with. We have the chemistry of this all is really incredible. Botanicals present some very unusual challenges. It's an art and a science, and you have been the godfather of the orthogonal approach. Why don't we just go there for a while and tell us, what is orthogonal? Why is this, in your judgment, a valuable way to approach identification and management of quality?
That's a great question, Loren. And, when we talk about orthogonal in analytical chemistry, we're talking about a secondary analysis to provide similar information. So perhaps doing something like an identity test with HPTLC, high performance thin layer chromatography, that fingerprints the phytochemicals, but we match that to references for authentication, versus using a microscope and doing microscopy, where we look at histological features of the cells and the structures of the plant parts under the microscope to confirm identity. And the reason I push these complementary techniques or orthogonal tests is because if you think of identity as a diamond, when you take one test and conduct it, you're looking at a facet. So somebody has got this cut diamond and you're looking at a facet, but that facet limits what you're seeing. You're not seeing the whole stone. When you combine some techniques, you get more data points. And a lot of times people say, well, if one test passed, why do you need to do another? And a great example of that is that we see right now a huge problem with mark. That's the botanical following extraction. So somebody has taken the botanical, extracted it, made their product. This mark used to go into compost or animal feed as fiber or what have you. But now other companies are buying that mark and they are re-extracting it. And that's this glut of these 4-to-1 extracts that have these barely perceptible phytochemical profiles. Or they take the mark and they mix in a little bit of extract so that it spoofs the HPTLC profile and resell it as a botanical. And if people say, well, the profile looks weak, well, phytochemical variation, harvest, blah, 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 which, all that stuff is real, but it's also used a lot of times to make excuses. You take that same thing that passed in HPTLC and you put it under a microscope and you see these frills of maltodextrin from the spray drying process, not part of the plant, obviously an exogenous adulteration of the plant. You often can see the cellular structures damaged and ruptured from the extraction process. So combined, those things circumvent adulteration. Another example would be looking at a mushroom product. Several years ago, we looked at a mushroom product. This is the last 10 years, not ancient history, and passed by TLC. When we looked at it under the microscope, we saw something very unusual. And because of my background in forensic microscopy, we determined it to be powdered glass. And powdered glass is an amazing sinister adulterant because it doesn't really show up on most chemical tests, and it's heavy and it can bulk materials up. So if you have glass recycling and it's getting pulverized to a powder, that powder can get blended back in. And we've seen lead powder, we've seen all kinds of things like microcrystalline cellulose, sand, you name it, in there. I've seen echinacea bulked with pyrite powder, and it's just an amazing thing. So only looking at one angle is always risky. And that's why, a suite of tests, including organoleptic, visual appearance, ash, we find a lot of adulteration with ash tests, microscopy, TLC. This suite of tests make a big difference. And that's why you see in monographs like USP, EP, JP, they don't just have one test to authenticate and pass a material as pharmacopoeial grade. There's a suite of tests, and those suite of tests taken as a whole form the picture of the product.
Naturally, I go to the master to explain, as you have done, the importance of using different techniques and approaches to really understand what you're dealing with. Very often I'll hear, well, you mentioned this, you have millions of dollars worth of equipment. I'm sure our consumers simply don't understand what the cost of quality is. And that starts with the people and the tremendous training necessary to be an expert in such a diverse and complex field. But also the equipment is exceptionally expensive. And in your experience, can you put a number to it? So a company that is really doing a proper job, what level of investment have you seen as a percent either of the cost of the product or the cost of operations? I'm asked this question a lot. People are trying to benchmark each other to figure out how much should we be spending on quality.
That's a hard question to answer because it depends on the product that you're making, the ingredients you're using, and how complex those ingredients are. If you're making a product with 10 or 20 botanicals and 5 or 10 different non-botanical ingredients, there's a significant amount of tests that need to be conducted. If your product is glucosamine hydrochloride capsules, very narrow range of testing. And, it could look like the person with the big complex mixture product is spending more on testing. And does that make them better? Not necessarily, because you do testing that's fit for purpose for the intended needs to meet your specifications. You want to make sure that your ingredient specifications are satisfied. And ingredient specifications are often an area with botanicals that I see some serious problems for the industry. But, it really depends. But one of the challenges today is, back in the day when you bought higher ticket items, they were usually with analytical, field upgradable. So you bought a mass spectrometer, they've come out with a faster scan rate that could actually field swap the main boards out or add chips or change things. Now it's not that way anymore. Things are moving so fast that you've spent $650,000 on a triple quad, and 7 years later, you've got a doorstop. So this is a big challenge right now. And if you think about how fast our smartphones and our computers obsolete, these analytical instruments are doing the same thing in most cases. We just put a new triple quad mass spectrometer in to upgrade our old one. And our old one has been working for several years as a very good instrument, still going, but the new one is 25 times as sensitive. And this is a two-edged sword because we can now see things we couldn't see before. And we talk about this in the analytical community as chasing zero. So when does it matter? I mean, how much lead is too much lead? How much aristolochic acid is too much aristolochic acid? In some cases for the FDA, if it's poisonous or deleterious, they say, if you can see it, you can't sell it. And so there's challenges out there, and a lot of specifications are based on things that are going to have to evolve with the changing science.
This is such an interesting question, Jim. Thank you for raising it. As we get faster, better, smarter, and our depth of understanding in testing will take us to these extremely small limits. We're challenged by regulation. Prop 65 is the case study here.
Yes.
How far do we go? And then you have plaintiffs' lawyers over here that are also paying attention. Our job is to get it right, is to produce a high quality, effective, and safe product for the consumer, understanding what these limits are that are both reasonable and practical from a business point of view. This chasing zero is going to be a continuing problem, one that we'll have to continue to debate within the industry. But I really appreciate your bringing insight onto that, especially as equipment ages and you have to replace it. This is a real challenge for many companies to keep current. And I admire those companies, and I've seen a whole lot of facilities and a lot of labs, and it's extraordinarily impressive to see the commitments that are being made today within an industry that 30 years ago was on the brink of extinction. We simply were not seen by FDA as either legitimate, nor do we have any regulatory status, and that all changed with the DSHEA, Dietary Supplement Health and Education Act, that passed in 1994. And that became a real motivation as GMPs came online, which were required by FDA and DSHEA. Where do you see us going, Jim? You've really helped us understand the capabilities of the technology. Now we have to understand the limits that we need to set so that we meet our obligations to our consumers. But we have to be able to do this in an affordable way. How do you see that? Where do we find that balance?
Yeah, it's a tricky thing, Loren, and there's a lot of things that I consider unreasonable or unfair. For instance, you're allowed a substantial amount of quinazine in broccoli and potatoes, and yet botanicals like ginseng, the FDA has taken a zero tolerance stance, and they've had a unofficial official limit at like 10 parts per billion. So the thing is that they've always been, well, you can't have it detected because if EPA hasn't set a crop limit for that residue, then it's a zero tolerance. This isn't realistic because we're in a global market, and you can have an organic crop that's exquisite and beautiful, and you've done everything right, and then the guy next to you is flying an airplane over his crop and spraying it, and you get overspray. You have water contamination, you have soil contamination, you have the contamination in air. In high alpine areas, they're collecting rainwater and there's microplastics in it because of how persistent this pollution is. Arctic ice cores have DDT. So how are we going to say no DDT? That's unrealistic. So I have a frustration with the speed at which government regulators have moved to solve these issues and come out with reasonable guidance. And the fact is that Americans eat more potatoes and broccoli than ginseng, and therefore that's where their focus is. But we got to focus here too. And for companies, I think where I see us going is, well, when I started 30 years ago, and I think anybody that's been in this industry can remember this, the labs all held their methods close. They were secret, they were proprietary, nobody was sharing. And the poor manufacturers, they would be, oh, I send this sample to 3 labs and I get 3 different numbers and I don't know what to do. And early on, our lab took a let's work together approach. So we were early involved in the NNFA's programs at the time, and then in the Institute for Nutraceutical Advancement that was around Loretta Zapp's brainchild there through their lab. And, we participated in collabs, we participated around Robbins. I was, of course, the founding methods committee on dietary supplements chair for AOAC. And we also participated in collabs there. And what's really changed is the spirit of collaboration. And if you go back to like UNPA and trying to come up with a method, it was like brokering a deal between Tehran and the US, through Qatar, because everybody's in the room. We're just on the verge of throwing punches. Nobody's sure they want to talk about things too specifically. Now you've got companies throwing in support for things, volunteering their in-house labs. Contract labs are involved. We have working groups. We have working groups through USP, AOAC, through ASTM, and we're all working together. People jump on, and it's like I tell people, you have an opportunity to be part of the solution, to push forward a solution that you think makes sense if you're the expert on a product. If you don't want to be part of the solution, you're going to be a victim of the solution other people come up with and standardize in the industry. Fortunately, most of our stakeholders are in the spirit of cooperation, because we know that bad news affects everybody in the industry and good things help our industry move forward. So that's a big change. And I think that cooperation and activism as a group, because we're now a very formidable force. This is not a small industry anymore. It's a major industry. It's a global industry. And we have some authority in which we can make change. So we can't be ignored. And we need to, take ownership and make the changes we need to. And some people have to be dragged along kicking and screaming. Most of us are forging ahead and plowing the road, and we're moving the rocks, and we're happy to be doing it together. Many hands make light work, and that's a big factor for what's been successful in this industry.
Well, Jim, I think you've given us the theme for the coming year is the spirit of cooperation, and it's great to hear your messages that is strong and growing within the lab community. And as I see it in other parts of the industry as well, realizing that we do our best work when we do it together. And so
Yes.
on that high note and optimistic note, I want to thank you so much for your many years of service, leadership, both intellectual and emotional, and in this spirit of cooperation. We would not be the industry that we are without your contributions, which have been many. So with that, thank you so much for joining us today. And I hope you come back. I have a couple of other things I'd love to talk about in another episode. But for now, Jim Kababick, founder, president, Flora Research Labs, thank you very much.
My pleasure. Good to be here.